We are now going to look at part 2, integrals with infinite discontinuities. Example E. Let's take a look at the integral from 0 to 3 of 1 over x minus 1 to the 2/3 power. Now, as you see, if we go from 0 to 3, we are passing through the number 1, and 1 is an infinite discontinuity. Because of that, this makes this an improper integral. So let's deal with it. So we're going to make this 0 to, we're going to make it to the point of discontinuity, 1 dx over x minus 1 to the 2/3. And then we're going to add to that the integral from 1 to 3 dx over integral x minus 1 to the 2/3. Now we're going to have to do each one of these individually. We're going to do this one and we're going to do this one, and if either one of them fails to converge, then the whole thing fails to converge. If they both converge, then the answer is the sum of the two. So let's first take a look at the one from 0 to 1 dx over x minus 1 to the 2/3. Alright, so we need a limit statement. This is very important. A lot of people will lose a lot of points if they fail to write this properly. This is going to be the limit from 0 to b. See, 1 is the infinite discontinuity point, so that's going to give a general marker b. And it's going to be the limit as b approaches. Now here's where people might lose points if they're not careful, where b approaches not just 1, but it's 1 from the left. See, we're breaking this from 0 to 1, we're approaching 1 from the left, and over here we'll be approaching 1 from the right. So this one little guy here, this little negative up top, is telling us we're approaching from the left. That's very important that you write that. So this is dx over x minus 1 to the 2/3. Okie dokie. So now this is the limit as b goes to 1 from the left, and the antiderivative is 3 x minus 1 to the 1/3. I'll let you contemplate that or work it out later or now if you press pause, but for now you're going to have to accept it. So then we continue in the same process that we've discussed in an earlier session. Limit as b goes to 1 from the left, so I'm going to write 3 b minus 1 to the 1/3 minus 3 times negative 1 to the 1/3, or simply negative 1. Alright, so this expression here is going to go to 0 if we plug b as 1, and this is equal to positive 3, so the limit is equal to 3. So this one here converges to 3. Let's take a look at the second one. Okay, so we need a limit statement, very important. This is the limit, and we're going to go general marker A for the point of discontinuity to 3 dx over, and make sure you know this, maybe write it now before I say it. This is going to be as A approaches 1 from the right, or from the positive side. Alright, the antiderivative is the same, so that helps with a little bit of work there. And so we have 3x minus 1 to the 1/3, and we're going to take that from a to 3, and that's going to come out to be limit as a approaches 1 from the right, 3 times 2 to the 1/3, when I plug in the 3, minus a minus 1 to the 1/3. Plugging in 1, this expression is going to 0, so that tells us that the limit of this respective integral is 3 times 2 to the 1/3 power. So in the end, each one converged, so the original integral here converges to the value of 3 plus 3 times 2 to the 1/3 power. Example F. Also, this integral passes through a point of discontinuity. That point of discontinuity is at 3. So, I'm going to break it up at that point, as you see here. Alright, so I potentially have two integrals to evaluate in order to find the answer. I'm going to look at the first one, 0 to 3 dx, x minus 3 squared. That's going to be the limit. Oh, do you know what I'm going to say here? This is the limit as b approaches, tell me, 3 from the left of 0 to b dx over x minus 3 squared. So this is the limit as b goes to 3 from the left. The antiderivative, negative 1 over x minus 3. Now, you certainly wouldn't do it that fast, but I have the privilege of having done it before talking about the video. 0 to b, so then this is going to come out to be the limit as b goes to 3 from the left, negative 1 over b minus 3, minus a minus, so plus 1 over negative 3. Alright, so the question then becomes, what about this? So if I know I can't plug in 3 for b, and this is specifically 3 from the left, so it's getting closer to 3, like 2.9, 2.999. So this is getting close to 0 with negative numbers together with the negative on top. So this whole thing is going to positive infinity. So what does that tell me? Well, it tells me that this particular limit is equal to infinity. I don't like saying equal to infinity. It approaches infinity. The limit does not exist. So if I look at this one, and this comes out to be infinity, I know right now, case over, that this integral does not exist. Sometimes people ask, well, what if I worked out this one? And what if this comes out to be negative infinity? You cannot say that infinity plus negative infinity is equal to 0. This is undefined in the positive direction. This is undefined in the negative direction. The result of that is not 0. The minute that one of them does not exist, the entire thing does not exist. So the answer to this question would be diverges. I'll put 3. Example G. Perhaps you want to press pause and work it out first. So this one does not pass through a point of discontinuity. One of the bounds represents a point of discontinuity, that bound being the 0. Please take a moment and write the limit statement to express this. Limit, this is the bound that is not defined in the domain, a to 1 dx over radical x, and this is the limit as a approaches 0 from the right. I'm hoping that you got that right. Anyway, I'm going to say this is limit a goes to 0 from the right, and really making some unnecessary work, but I'd rather write this as x to the negative 1/2 power. It's just going to be easier to do the antiderivative. So now we have the limit as a approaches 0 from the right of antiderivative 2x to the 1/2. I could choose to pull out the 2 or not, and I'll write it like this. So then this becomes the limit as a approaches 0 from the right. Plug in the 1, I get 2. Minus, plug in the a, I get 2a to the 1/2. This here will go to 0, so the entire thing will go to 2. Yeehaw! We say that the integral, which is actually the limit, is going or converging to 2. Converges. So you have to say it like that. Converges. Sort of important to emphasize.